A lot of people have been asking me recently about one of the posts I put up about where researchers had trained AI models on viral DNA and used them to design novel bacteriophage genomes. Some of these were AI computer-generated genomes, and they were synthesized and found capable of infecting bacteria. Now, these were bacteriophages, viruses of bacteria, not newly created human pathogens, and that distinction is important. In February 1943, in Trinity College here in Dublin, the great quantum physicist Edward Schrödinger stood before an audience and asked the question, what is life? And to an extent, we probably need to go back to this because we're in a situation now where we have AI actually writing genetic code. And this was all predicted, of course, in this wonderful book that Adrian Wolfson wrote some time ago, where he predicted that AI code could be used to write genomic sequences to actually produce new mammals and all the rest. So back in 1943, during the war, when Edward Schrödinger asked that question, what is life, he famously called it this aperiodic crystal. Now, this was a decade before Watson and Crichton described the double helix. But perhaps the most extraordinary thing is where the question has taken us now, 83 years later. We're no longer simply trying to read the code of life, we're beginning to ask artificial intelligence to write it for us. So Schrödinger asked, what is life? Then biology discovered life stores information, and we learned how to read that information. Then we learned how to edit it, and now with artificial intelligence, we're beginning to write it ourselves. And this, no doubt, brings us enormous new possibilities in therapeutics, antimicrobial strategies, synthetic biology, but also profound questions about biosafety and responsibility, as I was chatting to somebody on the train on the way back from Dublin regarding this. So the question for our generation is no longer simply what is life, but it's probably more how far should we go in learning to write it. Now, a good friend of mine has recently had discussions with me regarding where does life come from. And many of us carry the same pictures in his head, that is dead chemistry one moment, and suddenly a spark comes from the sky or whatever, and suddenly we have life. It's a beautiful image, but it's totally wrong. Nature doesn't work in switches, it works in gradients. Think about first what we mean by alive. Movement, reproduction, feeding, responding to the world. Now, there's one sure thing, none of these things arrive fully formed. Each of them exists in half versions all around us in plain chemistry. If we look at a crystal, it grows and can copy its own structure. Is that the beginning of life? Well, it's certainly a crude ancestor of reproduction. If we take an oil droplet and we put it in water, it moves, it splits in two. That's primitive motion and division. Some molecules catalyze the making of more molecules like themselves long before anything we'd call a cell. I personally believe that life is what happened when enough of these half abilities gathered in one place and began enforcing each other. A membrane to hold things in, a molecule that copies itself, a cycle that captures energy. Each step is extraordinary chemistry, but stack them together over hundreds of million years and you drift slowly, imperceptibly from a mixture to an organism. You know, there was never a first living thing, just there was never the first speaker of English, Latin, or, it all evolved from one generation to the next, and no parent ever spoke a different language than their child. I believe that chemistry became biochemistry, biology the same way. And the border is still blurred today. A virus reproduces, it can't move, it can't feed on its own. Is it alive? There's no clean answer. And that's exactly what you'd expect. Life is a spectrum, not a spark. Many of us carry the same picture. Dead chemistry one moment, a spark from some great creator from above, and then suddenly we have life. And that's certainly not the way it works. I understand why people believe that is beautiful, but the evidence tells a different story. Nature doesn't work, as I said, in switches, it works in gradients. Let me show you what I mean, not with philosophy, but with chemistry that you can test. In 1953, a young student called Stanley Miller put water, methane, ammonia, and hydrogen in a flask, the atmosphere of early Earth, and he ran electricity through it to mimic lightning. Within a week, the water turned brown. It had made amino acids. They're the building blocks of protein from nothing but gas and a spark. The experiment has been repeated hundreds of times since with different starting molecules, and it still works. Let's look at meteorites, particularly the Murchison meteorite, which fell on Australia in 1969 and which I saw part of when I was there. It contained over 90 amino acids, formed in space with no life anywhere near them. The universe, it turns out, makes life's ingredients routinely. The next problem is, how do you get a container? A cell needs a wall. And there's the remarkable thing. Fatty molecules in water assemble themselves into hollow spheres just like a membrane, spontaneously. No guidance needed. It's simple physics. One end of the molecule loves water, the other end hates it, and so they arrange to form a membrane. Shake them up and they divide. Then people talk about copying RNA. We know that's the simpler cousin of DNA, and it can do two jobs at once. It stores information, and it acts as a machine that cuts and joins together other molecules. We know in laboratory experiments, copying pieces of itself. A single molecule, in many ways, is both a blueprint and a builder. That's the bridge, really, between chemistry and biology. And people ask about energy. Deep on the ocean floor, hydrothermal vents pump out warm, mineral-rich water through rock riddled with tiny chambers. These are natural test tubes with chemical gradients running across their walls. The same type of gradient that every living cell on Earth uses to make energy today. 4 billion years later on, your cells run on the same trick as the rock at the bottom of the ocean. Each of these are steps that have been observed. None of them requires anything beyond ordinary chemistry. What we haven't done is watch them all assemble in sequence. That took the Earth 100 million years, and it's had 4 billion year head start on our laboratories. So every gap seemed to demand a miracle that one by one has yielded back to chemistry. There was never just a first living thing. Just as I said, there was never a first speaker of French, Latin. It all came one generation at a time. And as I said, chemistry became biology in pretty much the same way. Some people feel that this explanation diminishes life. I feel the total opposite. A universe where matter itself carries the seeds of movement, of copying, of striving, where life grows up from the beneath rather than being dropped in by somebody from above. All that to me is a much deeper wonder. Now, as I said, I've kept some honest concessions here. What we haven't done is watch all of them assemble in sequence, because to an extent, pretending abiogenesis is a solved problem is really not what I'm saying. I suppose also life didn't descend upon us, it grew from beneath us, and that to me is much more remarkable than any magic. So we've gone from showing where AI can now write genetic code to make viruses, to Schrödinger, what is life in Dublin, rather Schrödinger in Dublin saying what is life, to Watson and Crick working out the genetic sequence and the information of life. And we move that now to where AI can write code and make their own viruses that are not only synthetic, but are functional and can infect bacteria. They'll not infect humans, but we obviously don't want that to happen. To this wonderful book, which shows that AI in the near future will be able to write code all the way to forming organisms, maybe even like that chick behind me. And that's out and over from Dublin on What is Life. Hope it wasn't too complicated.
Prof. Patrick Treacy said aging isn't a deficiency disease, it's an inflammatory one. I'll be honest, I really expected a catch, but it turns out the evidence holds up. His upcoming book is based on clinical evidence, not marketing. He tracks landmark trials like Cantos to show how to extinguish the fire of chronic inflammation.